In this video, we're going to talk about L'Hopital's rule. First off, L'Hopital's rule here, if you take a look at the spelling of L'Hopital's name, uh, it's spelled like hospital. Sometimes you'll see it without the S in there. That has to do with the French language and how it works. And nowadays, I believe they put like an accent over the O, and that makes this S here kind of redundant. This is I guess, the old way of spelling the name. So anyway, that's just the way that I'm used to spelling it, and so sometimes you might see it with no S in there. Regardless, right? It's L'Hopital's rule, okay, without the S. All right, so L'Hopital's rule is a powerful technique for taking the limit of functions, especially when, or actually exactly when, right, you get an indeterminate form in the limit. So if you recall back to when we were talking about limits, sort of the worst possible case that you could have is the 0 over 0 case. Okay, so if you have the limit of the quotient or division of two functions and you get 0 over 0, or you get plus or minus infinity over plus or minus infinity, meaning if I take a look at the limit of the top by itself, it goes to infinity or negative infinity. If I take a look at the bottom function by itself as x goes to c, then I get positive infinity or negative infinity. Okay. So if I get either of those two situations, right, then what L'Hopital's rule says to do, it says, hey, the limit as x goes to c of f of x divided by g of x, it is equal to the limit as x goes to c of the derivative of f divided by the derivative of g. Okay. All right. And so here c, right, the limit as x goes to c, it can be any real number. So it could be the limit as x goes to any real number from the right or from the left, or the two-sided limit. It also can be the limit as x goes to infinity, or the as x goes to negative infinity. So any of those types of limits here. So if you get 0 over 0, or plus or minus infinity over plus or minus infinity, then take a look at the limit as x goes to c of the derivative of f over the derivative of g, and see if you can figure out what that limit goes to. All right, so let's take a look at our first example here. Our first example is the limit as x goes to 0 of sine of 2x over x. All right. So first thing to do is, it's the limit as x goes to 0. So what we want to do is put in 0 and see what we get. On top we get sine of 2 times 0, which is sine of 0, and 0 on the bottom, and sine of 0 is equal to 0. So we do indeed get the 0 over 0 indeterminate form here. So L'Hopital's rule applies. So what I would do is take a look at the limit as x goes to 0 of the derivative of the top. Well, on the top it's sine of 2x. So using the chain rule, I can take the derivative. I would get cosine, leave the inside part alone, multiply by the derivative of the inside part, which is 2. So 2 cosine 2x, that's the derivative of sine 2x. And then I would put that derivative over the derivative of the bottom function. The bottom function x, right, the derivative of it is just 1. So this is what I get when I look at the limit as of the derivative of the top over the derivative of the bottom here. Okay. Now take that limit, and so it's the limit as x goes to 0, and I plug in 0. So on top I get 2 cosine 2 times 0. On the bottom I'll just have 1. So 2 times cosine 0. Well, cosine 0 is equal to 1, right? So on the top I get 2, on the bottom I get a 1, and that comes out to be equal to 2. Okay. So L'Hopital's rule says that the original limit, the limit as x goes to 0 of sine 2x over x, has to be equal to 2 also. Okay? So this is the general kind of approach that you're going to take using L'Hopital's rule. If you get 0 over 0 or infinity over infinity, then you want to take a look at the limit of the derivative of the top over the derivative of the bottom, and see if that limit comes out to be a number, or infinity or negative infinity, or does not exist. And in any of those cases, right, As long as you don't get the indeterminate form, the original limit, right, is equal to that. All right, a couple of very important notes, right? Number one, make sure that you check that L'Hopital's rule applies before using it. In other words, make sure that you are in the case where you have 0 over 0 or infinity over infinity, right? Any of the variants of infinity over infinity. So that must happen in order for you to apply L'Hopital's rule. If you don't check that, right, then what will happen is you can apply L'Hopital's rule when it doesn't work, all right, and then you'll get an incorrect answer. So make sure and verify that L'Hopital's rule applies before you use it. Secondly, don't confuse L'Hopital's rule with the quotient rule, right? They don't have anything to do with each other, okay? The quotient rule is if you want to take the derivative of f divided by g, okay? Here, we're not doing that, right? That's not what L'Hopital's rule says. It doesn't say take the derivative of f divided by g, right? It says if you've got a limit and it's f over g, if you're in the 0 over 0 or infinity over infinity case, then just look at the limit of the derivative of the top over the derivative of the bottom, okay? So nothing to do with the quotient rule. The two mistakes that people make here, generally speaking, are they want to use L'Hopital's rule, and instead of taking the derivative of the top over the derivative of the bottom, they take the quotient rule, right? That's not what L'Hopital's rule says. The other thing is that after people do the L'Hopital's rule section, then they forget about the quotient rule, and so they want to take the derivative of f over g. That's the quotient rule, but instead they do the L'Hopital's rule version. So make sure you understand, right, that they don't have anything to do with each other. You're going to have to remember some of the limit facts from Unit 1. So one of the limit facts from Unit 1 is that if I have any polynomial, then the limit as x goes to infinity or negative infinity of that polynomial is either infinity or minus infinity. Okay, so the limit as x goes to infinity or minus infinity of any polynomial is either infinity or minus infinity. All right, the natural exponential function e to the x, the limit as x goes to negative infinity of e to the x is 0, and the limit as x goes to positive infinity of e to the x is positive infinity. Take a look at the graph of e to the x, right, and you can see that. The limit as x goes to negative infinity, well, as I go off to negative infinity, the graph gets closer and closer to the x-axis, so that limit is going to be 0. And the limit as x goes to positive infinity, well, if I go this way, right, you can take a look and see that the graph goes up very quickly, right, and so it goes off to infinity there. So those are two important limits to remember when you're working these problems. Also, the natural logarithmic function, right, if I take a look at these two limits here, the limit as x goes to 0 from the right of the natural log function is negative infinity. The limit as x goes to positive infinity of the natural log function is positive infinity. So again, if you take a look at its graph, you can kind of see that behavior there. Right, so the limit as x goes to 0 from the right, the function goes to negative infinity here. The limit as x goes to positive infinity, that one looks questionable from the graph, but it does turn out that this graph just keeps going up and up, right, the farther you go off to the right over here. So those are another set of important limits to remember. You're also going to need this limit fact here. This limit fact says that if the limit as x goes to a of f of x is L, so this is just a number here, any number, and the limit as x goes to a of g of x is either infinity or negative infinity, then the limit of the quotient of those two things is going to go to 0. So here, the top part is getting closer and closer to some fixed number, while the bottom part is getting either really, really big or really, really small. Either way, when you perform that division, like for instance, say the top is getting closer to 1, and the bottom is getting bigger, so like 1,000, 10,000, a million, a billion, 10 billion, right? If I keep dividing a number by bigger and bigger numbers on the bottom, the result, the quotient of that, is going to go to 0. Okay. So all of those limit facts are going to be used in the examples that we are going to take a look at for L'Hopital's rule. There's one other thing that you need to know from the limit section that we did before, and that's the limit of all the power functions. If you go back and look through those notes, we talk about the limit of all of the different power functions that you could have and what they are.